right, thanks for showing up for the last session of the day. I think. No one's going to another session, I hope. Parties after this? Someone's excited. All right, well, I'm Josh Caplan. I lead product management for OneLake in Fabric. And OneLake is going to be the center of gravity across your entire multi-cloud organization. We often refer to OneLake as the OneDrive for data. And today I'm going to share more details on why and what value OneLake will provide to your organization. So organizations have these visions of pristine data lakes, which provide one place to land all their data. Now, having it in one place is supposed to make it easier to break down silos, blend that data together, analyze it together. Having it in one place should also simplify the management of it, the governance of it, the discovery of it. It's easier to look in one place than five, right? And make it really easy for all applications to find it and use it. That's the vision, that's the goal. Reality is a little different. This is very difficult to achieve, this vision. Analytics with data lakes is a lot like file sharing was prior to OneDrive. If anyone remembers back to those days, how did we share files? We got servers. We would rack them. We'd set up folders on there. We'd set those up as network file shares. We put some ACLs on there, and you know what? It shared files. It worked. But we used storage to give us a file sharing solution ourselves. OneDrive came along and really changed the game by giving us a SaaS service that shared files. And it's evolved a lot from just file sharing. It's evolved into collaboration over files. It's evolved into governance over files. Today, instead of buying data lakes, you buy storage. And you implement a data lake pattern on top of that. This is not easy. Pretty quickly, that one pristine data lake goes out the window. In order to achieve that, you really got to get multiple parts of your organization to work together, agree on standards, agree on what can go into the lake and what can't. And it's a huge coordination challenge. So that popular data mesh patterns kind of emerged, which is meant to solve that coordination challenge by having each part of the organization, each business domain, really run their own lake. And while it can help with that coordination challenge, now you have lots of resources to manage, lots more overhead. The end result's almost always the same. You end up with multiple siloed lakes for different business domains. Sometimes this is across Azure, sometimes this is across multiple clouds. Then you need to build solutions to solve this problem and really break down those data silos. How do you do this? Well, often you're moving data and you're consolidating data, you're copying, you're duplicating. And even once you're able to break down those silos and consolidate data, most users, most applications don't know how to talk to the lake directly. So we build a serving layer. Cubes, data warehouses, marts, Power BI data sets, Power BI semantic models. It's going to take some time. These are not just references of the data in the lake. These are copies of the data from the lake. At best, sometimes they're copies of the data from the lake. And before you know it, you got data moving all over the place. And you're building systems to manage this. You're building systems to keep things up to date. You're building systems to govern the data. And you're getting woken up in the middle of the night when the data's not up to date. But you do this. There's a lot of value you can get out of the data when you build these systems. OneLake aims to provide you a data lake as a service without you needing to build it yourself. OneLake is your organization's single unified multi-cloud SaaS data lake, eliminating data duplication and integration tax. And for years, you've had OneDrive for your documents. And now you have OneLake for your data. So every Fabric tenant will always have exactly one OneLake. You'll never have zero. You'll never have more than one. We kind of got the name, so it's going to always be one. The concept of a tenant, though, is a unique benefit that we have in a SaaS service that we didn't have in the PaaS world. We know exactly where your organization begins, and we know where it ends. This provides a natural governance boundary. All data lands in OneLake inside this governance boundary. And the admin sets this initial boundary. Any data that lands inside of it will automatically take part in out-of-the-box data governance, such as data lineage, data protection, certification, catalog integration. And all data is ultimately under the control of that tenant admin. However, it's important that different business groups can still work independently without going through a central gatekeeper. We don't want to end up in that, called the data mess pattern that we saw in the beginning. So just as an Office user does not need to coordinate with their admin to create a new Teams channel or SharePoint site, OneLake offers similar distributed ownership through workspaces. Excuse me. Different workspaces enable different parts of the organization to work independently while still all building to the same data lake. Each workspace can have its own administrator, its own access control, its own region and capacity for billing. And creating a workspace is very lightweight. It inherits the initial rules set by the attended admin. And you don't have to re-implement them. Now, each workspace can talk to each other without you having to string together private endpoints and getting them to work together. Now, workspace admins can add more governance and more controls and tighten down the restrictions on the workspace even further than the attended admin had set. Taking this a step further, though, workspaces are meant to align with different teams and different projects. A single business domain is going to have many workspaces. Following that popular data mesh pattern, we've made domain an actual feature of OneLake. Domains provide a governance boundary in between the workspace and the tenant, enabling domain admins to have more granular control over all their workspaces in their business area. Everyone is now able to contribute to OneLake. Now that everyone is able to contribute to OneLake, customers will often ask me how to prevent certain users from doing so. They don't want their official IT blessed data to be sitting next to just some other data that someone brought in. And I always say that you really should not prevent someone from bringing data to OneLake. It's the easiest place to land the data. And if they don't land it there, they're going to land it somewhere else. And if they land it somewhere else, you don't know if it's governed. You don't know if it's secured. And you don't know how that data is actually being used. Land it in OneLake. This will be taken care of by default. Now, you can use data endorsements to tell your users what is your certified sources of data. And you can mark data as officially certified. And you can do this by domain, so that you can have the sales domain officially certified data. And when you do this, the important data, the certified data, should rise to the top of the lake while the rest of the data starts to fall and sink to the bottom. But if this doesn't happen for some reason, you can see this, and you can take action based on that. You might also be thinking that your organization can't have just OneLake because you're in multiple countries, and you have rules that say your data has to reside always in those countries. OneLake covers this by spanning the globe as well. Different workspaces can reside in different regions. And when the workspace resides in that region, the data will also reside in that region. How can we do this with just OneLake? Separate the lake from storage. Remember, OneLake is not storage. It's a data lake. It's built on top of ADLS Gen 2. We actually have hundreds of thousands of storage accounts right now that are backing up OneLake. And they're all over the world. And we'll have them in different regions. But OneLake will virtualize this away into one logical lake without you needing to manage those additional resources. Now, when you land your data in OneLake, we're going to land it automatically with zone redundancy. So if something happens in a data center, you still have a backup within that data center itself. With the GAF fabric, we're also introducing the ability to set geo-redundancy for your workspaces. And that way, we'll actually replicate it to another region entirely in case something actually happens to the full region. Now, so far, we've only been talking about data storage. It's compute that powers all the analytical experiences in Fabric. Now, in Fabric, the compute is totally separate from the storage. Different Fabric workloads can leverage multiple analytical engines when reading and writing data to OneLake. We have a Spark engine that powers our data engineering and data science experiences, a T-SQL engine that powers our data warehousing experiences, a KQL engine that powers all our real-time analytics, and the analysis services engine, which powers all the BI and reporting in Power BI. Multiple engines with different strengths, all able to work over the same data in OneLake. It's these engines that the different workloads use to write to their data items. A data item is like a warehouse, a lakehouse, a semantic model. And they write this data to OneLake. All of them write their data to OneLake in files and folders. Ultimately, it's all files and folders at the end of the day here. We've not created any new proprietary file formats. All tabular data is stored in Delta Lake Parquet files by default. And because we've standardized all our engines around Delta Parquet, the same data that one engine writes can be read by any other engine. And they can do this without any import or any data duplication. So even the analysis services engine, which powers all Power BI reports, can now page delta parquet data in from OneLake directly into memory and serve reports in what they call the new direct lake mode. This is a concept we call one copy. One copy aims to get the most value possible out of a single copy of data. Thanks to one copy, the decision of which engine to use to build your analytics solution can be separated from how the data is going to be consumed and used later. It's now a matter of preference. You may have some teams who've been working with data warehousing for years and been working with T-SQL and building and transforming data through stored procedures. They can do this with a data warehouse. If your data engineering team is more oriented to Spark rather than SQL, they can use the full power of Spark and notebooks to transform and load data into a lakehouse. Each team can build their solution their way while still contributing to the same data lake. There really are no silos here. And with open access for OneLake, the same is even true for teams using engines outside of Fabric. OneLake is not just a Fabric data lake or a Microsoft data lake. It's an open data lake. In addition to being built on ADLS Gen 2, OneLake also supports the same ADLS Gen 2 DFS APIs and SDKs, making it compatible with existing ADLS applications like Azure Databricks, Azure HD Insights, and several more. So tenants will appear as one big storage account, with different workspaces appearing as containers, and then data is organized into folders under that. So if you've worked with ADLS in the past, this schema should look very familiar. Addressing OneLake is the same. There's no need to remember multiple storage accounts because there's only ever one storage account for OneLake. It's OneLake. And then the workspace goes into the container portion of the URL. And then the item, name, and type are all part of the path to the data. Let's actually look at this in action and just see how easy it is to read and write data to OneLake. So you can see all my Fabric workspaces listed here. And just like creating a Teams channel or SharePoint site, creating a new workspace is actually very lightweight. I'm going to go into an existing workspace here, and you see my data item. My data item happens to be a data warehouse. Going into that data warehouse, you're going to see a single schema here and a single table with some data in it. This should look similar to any T-SQL data warehouse experience you've ever worked with. But all this data is actually stored in OneLake. And we can see it. We can see this data. OneLake is the OneDrive for data, so of course we can actually see it in Windows, just like you can for OneDrive. Here you see the same list of workspaces, but this time they're just folders. Going into that workspace, I see that data warehouse. Going into that data warehouse, I see a folder that will contain all our tables. I see that schema. And I see that table that we just saw. Now I'm going to write a new T-SQL statement that creates a new table called sales. I'm going to insert just one single row of data. Going back to Windows, I now see a new folder for that table. Going inside that folder, I'm going to see the Delta log. And I'm going to see the Parquet file that holds that one row of data. So what this means is if you know how to write T-SQL, you can write Delta Lake files to OneLake. And if you work with any application that knows how to work with T-SQL, it can read and write data to OneLake. You don't have to learn any new skills. All roads here start to lead to OneLake. So let's look at a couple other ways to bring data in. Going back to the workspace, I'm going to create a new lakehouse. The lakehouse is the most lake-like data item. And what I mean by that is the things that you do today in ADLS Gen 2 containers, you can do in a lakehouse. It supports both structured and unstructured data. So OneLake is a data lake as a service, and we can't call it a data lake unless we support all types of files. For example, I have some image files sitting locally on my machine. I can go back to Windows, and I can just copy them in. Truly binary files here. And within seconds, you'll see these available in the UI in OneLake. Now finally, I work with a data engineering team which uses notebooks and Databricks to build out their tables. Those notebooks currently read from one Azure storage account and write to another one. Now what if they wanted to store this data now natively in OneLake? They can do this very easily. They can start by grabbing the file path for the tables folder in this lakehouse. And grab the ABFS path. And then let's flip over to the Databricks notebook. You can see where they're reading from the first storage account and then performing a bunch of transformations before writing the data back to another account. All they need to do to write this data to OneLake is change this file path. You'll see in the file path the workspace name and the data item name. Then once this runs, we can go back to the lakehouse and see our results. Now, because we're writing this to the tables section of the lakehouse, and because it's in 𝗬𝗲𝗸𝗀 format, you don't see files here. You see actual tables. These tables are automatically recognized and ready to be used with any Fabric engine. So OneLake's open access APIs are not just for writing data to OneLake. This week, we also introduced the public preview of Azure AI Studio. This is Microsoft's groundbreaking platform for AI developers. Azure AI Studio brings together pre-built AI services, machine learning models, content safety services, and responsible AI tools for privacy, security, and compliance to help organizations move faster from idea to impact. Through OneLake's open access APIs, both structured and unstructured data from any Fabric data item can be used as a data source for AI Studio. OneLake now serves as that connective tissue to build your generative AI-powered apps, powered by your own data. So as you can see, all roads here start to lead to OneLake. Any Fabric workload will bring its data to OneLake. We saw how you can do it with SQL. You can use the data factory workload, and it's to take data from over 150 different sources and bring it into OneLake. We just announced Power BI datasets in import mode can start to land their data in OneLake. The KQL engine, the Kusto engine, is landing its data in OneLake already. But in addition to that, anything that works with ADLS Gen 2 will work with OneLake. Now, OneLake is an open storage system with open APIs and open file formats. If you already have your data in an open storage system, you shouldn't have to copy it into OneLake, though, to use it with Fabric. We have multi-cloud shortcuts, which will let you virtualize data across clouds into a single logical lake without any data movement or duplication. So let's look at how. Going back to our last example, we had built that data warehouse. It had one sales table in it, and it had a very single, lonely row of data in there, very realistic. But other business domains in our organization want to combine that sales data with their own data in a lakehouse and get a full view of their business. Now, they don't need to extract the data from the data warehouse anymore to do this. Everyone's working off the same OneLake. So let's flip over to that data engineer in the marketing domain and see how they would do this. They would start by creating a shortcut and selecting OneLake as the source. This brings up the OneLake Data Hub, and it's going to show them all the data in OneLake that they have access to. They can filter this down for just the sales domain if they want. And in here, you're not going to just see the sales domain data, but you're also going to see the endorsements of that data. You can see what's been officially certified and what hasn't. And here you see the data warehouse that we built earlier. Going in there, I'll see the list of tables and our sales table. Once we create this shortcut, we'll now see this sales table in our lakehouse, and that one lonely row of data will appear here as if we had copied it. However, no actual data movement here has occurred. Not all the data they need, though, is in OneLake, or even Azure. So customer data, for example, resides in an Amazon S3 bucket. Any Amazon S3 data can also be shortcutted into OneLake. This data happens to be stored in 𝗬𝗲𝗸𝗀 format. So I can take the path here, and I can go create a new Amazon S3 shortcut. I'll provide the path to the data, give it an account key, something that has access to the data. And then finally, we'll just give it a name before creating it. Within a few seconds, the customer table will appear in our lakehouse with all its data. but there's no physical migration here. This data is living and residing in Amazon S3 and appearing here in our lakehouse. Thanks to 𝗦𝗽𝗀𝗶𝗸, this data can be used by any Fabric engine. And because we've integrated this so low in the stack in the storage layer, all features of the engines on top of us just work. They don't even know that this data is coming from a shortcut. We have to do extra work to actually make it show up with that icon in the UI. Using the T-SQL engine here, I'm going to join the customer data coming from Amazon S3 to the sales data that actually natively resides in OneLake. It joins. I could have shortcuts from multiple places here. It'll join. Since shortcuts only reference the data from the original location, there's no need to maintain copies of data. So let's go back to that original data warehouse and finally add that second row of data. Now, once this row's been inserted, there's nothing else to do. The consumers of this data, whether it's a shortcut or through any other means, just rerun their query, and the data is going to be there. You don't have to worry about accidentally using a stale copy of data, or the pipeline didn't run today, I have to go back and check it. There's only ever one copy of data. You'll always see the latest results. So it's shortcuts that provide the connections between domains and clouds so that data can be virtualized into a single data product without data movement, data duplication, or even changing the ownership of the data. As you saw in the last demo, the owner of that data warehouse is solely responsible for updating the data in that data warehouse. It flows through. Shortcut's nothing more than a symbolic link. It's metadata. Think of it creating a shortcut in Windows. You create a shortcut in Windows. The shortcutted data, or files in that case, will appear in the shortcut location as if you had physically copied it. But there's no data movement occurring. If you already have existing data lakes in ADLS Gen 2 or Amazon S3 buckets, use multi-cloud shortcuts, and those lakes can continue to exist and be managed outside of Fabric. You don't need to migrate data into Azure to use Fabric. Everything gets mapped to the same unified namespace and can be accessed using the same APIs. I can run a T-SQL query on top of Amazon S3, as you saw. I can use the ADLS Gen 2 APIs to get to Amazon S3 data. The applications don't need to know where this data is coming from. We've recently launched a preview of shortcuts to Dataverse. So if you are using Dynamics or Power Apps, your data is already in Dataverse. And with one click, you can actually virtualize this into OneLake through shortcuts to Dataverse. And I'm happy to announce that today, as part of the Fabric GA, this is also generally available. And then earlier you saw how Azure Databricks could directly read and write data to OneLake through OneLake's open access APIs. However, you're most likely already storing your Databricks data outside of OneLake. So there's no need to move it. And we want to work on the same copy of data, so there is no need to move it. Databricks can directly be shortcutted into OneLake, whether that's coming from Amazon S3 or ADLS Gen 2. And we're hard at work with the Unity Catalog team on Databricks to bring an enhanced shortcut experience to work directly with Unity Catalog. So more on that coming soon. So as you've seen, shortcuts can bring data from other platforms which support an open storage layer. And they do this without any data movement or data duplication. Now this is becoming a popular trend, moving to these open storage layers. But not everyone's there yet. A lot of data is still in proprietary formats. A lot of data is still in places where we can't access it from. So what do we do in those cases when there is no open storage layer? Priya's going to come on stage and now complete our picture with mirroring.
Thank you, Josh. So folks, super excited to be here. I'm Priya Sathy. I own data warehousing at Microsoft in Microsoft Fabric. And as Josh talked about, our job here with Microsoft Fabric is to really simplify the way you get your data all into one place for the purposes of analytics and AI. And we're super excited to bring to you mirroring. And I'm going to spend the next 20 minutes. I know I'm between you and beer time here this evening, so I'm going to be quick and talk about mirroring and deep dive into what we've built for mirroring. So if you think about your current data estate, most of you have this. You have a plethora of applications, you have databases, data warehouses. Shortcuts are great, and Josh talked about shortcuts when you can actually shortcut to that data. But in the case of databases, data warehouses, many of them have proprietary storage formats. Take, for example, SQL Server. You have MDF and LDF files. It does store it in a storage account and as MDFs and LDFs. What do you do with that? You can't really shortcut to it because you can't make sense of it. So what do you normally do, which most of you guys have probably built already, is you start extracting that data out of the database, you transform it, normalize it to some standard. You've most likely adopted a standard. Maybe it's Delta, maybe it's not. And once you've standardized it, then your data scientists, your analysts can all get access to it. Now, the problem with this is a cumbersome process. It's a long project, potentially. It's costly. That's project costs, support costs. And most likely, the data is also not real time. Many customers tell me they do batch jobs once a day, 24 hours a day. But data is growing so rapidly, users want insights, and they want insights now to make business decisions now. And if there's missing data, what do they end up doing? They end up going to the data source, that database, the operational system, the operational store, to query it to get the latest and greatest insights. So we're announcing mirroring is going to be coming soon to you in Fabric. With mirroring, you can seamlessly connect all of your databases and data warehouses in your data estate into OneLake. So let's talk about, the value proposition here of mirroring. So here, mirroring helps you centralize your entire data estate in one place in Fabric. So you don't have to go to many different places to build your analytics and get insights. It enables you to add any of these databases and warehouses with zero ETL. Now, if today you use pipelines, you build ETLs, jobs, you can continue doing that. But here, mirroring reduces that friction, and you can do that without any ETL. Once you start mirroring, you will get the ability to edit your source database. A full editing experience is available within Fabric. And data behind the scenes is replicated into Delta format into OneLake. And this is in near real time, and I'll talk about how it's in near real time. Once it's in Delta format, Josh talked about this, all Fabric experiences get immediately unlocked because data is in that Delta format. You don't have to do the heavy lifting to convert the data into Delta format. We did that for you, and all those experiences in Fabric that you've heard about for the last 48 hours are going to work for you. Your analysts and data scientists also have access to this near real-time data. And the best part is we now keep the analysts and data scientists away from executing heavy-duty queries on those operational systems. You can have your operational systems work on transactions, get the data in, and separate out the serving and the analytical queries and those AI models off into Fabric. So let's talk about the mirroring architecture. So at the core of this is a new artifact that we have introduced into Fabric called the mirrored database. Now the mirrored database is what connects to any of the operational data stores, data warehouses that are out there. In it, it has a full editing experience. I'll show you in the demo. Now, as the underlying database has proprietary storage format, what we do is we use change data capture technology. Many of you know most databases and warehouses support CDC technology. And we've built a replicated that does a high-speed, low-latency replication of that data and converts it on the fly into Delta Parquet and lands it into a SQL Analytics endpoint consumption replica in OneLake. And That is how all of the experiences, whether you're talking about warehousing experiences, Power BI, Direct Lake Mode, data science experiences, all of these get unlocked. Now, deep diving into each and every one of these, here you see in this example is a Cosmos DB database that's mirrored into Fabric as a mirrored Cosmos DB database. Now, the Cosmos database can be accessed from right within Fabric. You don't have to go to the Azure portal in order to do your management jobs. Everything that you did in Azure can be done right from within Fabric because of the editor. And all these databases that we bring into Fabric that can be mirrored will be available with editors. And this can go across clouds too. Your database can be in any cloud. Now, the near real-time replication that I'm talking about here, you'll get granular controls for managing your replication. You'll be able to configure exactly what you replicate. You may not want to replicate all your tables, and you might want to subselect, so you get full control. That's in your control. How we do it is once you decide and start off the mirroring process, we create an initial snapshot of your database. And then after that, we keep every transaction in sync with that OneLake replica. And that replication, as I mentioned, uses change data capture. And the transforms to Delta are automatically done. You don't have to do anything at all, and I'll show you that in the demo as well. And we also map the data types to the closest Parquet data types. Now, one other thing customers have asked me, hey, what about CDC putting extra pressure on my operational system? We've actually built intelligent logic in here that determines when the source has changed, ensuring that we don't unnecessarily put extra compute on the source. And in addition, we also give you very, very detailed monitoring, and you can go look at the status at any point in time. So if you have different databases in your enterprise data state, Cosmos, SQL, anything else that's in there, you can easily just mirror them and start doing cross-database querying, which is quite amazing, without doing that ETL process to land your data into Fabric and all the conversions into Delta. All the data science experiences, the last 48 hours, we've talked about Copilot, and we've talked about how everything in Fabric embraces AI, and you get Copilot experiences. All of those get unlocked. And Power BI Direct Lake Mode also gets unlocked. So you get blazing fast performance, blazing fast reporting performance right over data that's in OneLake, and you don't have to execute those direct queries over your databases. So I just want to talk about roadmap before I jump into the demo. So at this point in time, we're in private preview with Azure Cosmos DB, with SQL DB, and also Snowflake databases. And in the next year, next calendar year, we will be adding more of our first-party and third-party databases pretty quickly. And you can expect to see all of Microsoft first-party databases, all versions of SQL Server 2017 and up, Postgres, SQL, MySQL, all getting ramped up and available for mirroring into Fabric. So with that, I'm going to roll a video and talk you through the demo and show you exactly how mirroring works. All right, so here I am in Fabric Data Warehouse homepage. And I have a bunch of new tiles that let me mirror my SQL DB or my Cosmos DB, Snowflake, SQL Server, plenty of others. In this scenario, in my enterprise data estate, I have my sales transactions in a Cosmos DB. I have a partner who shared their Cosmos DB, their Snowflake database with me, and I also have some customer transactions in SQL. So I want to mirror all of this because I actually want to do a cross-join between my sales and customer data. So here I start with a Cosmos DB mirror. All I have to do is just give it a name. That's it. I don't have to provision resources, no setup, nothing. All of that is instantaneously done for me. So I go ahead and I have an existing connection to Cosmos DB, and I pick the database that I'm interested in that has my transactions. Decide to mirror all my data, and I click on Mirror Database, and that's all I had to do. So that process of mirroring, converting to Delta, is initiated behind the scenes. So here you see, if you've used Cosmos DB, you'll see this is a very familiar editor, which shows me all of my containers, my items, and I can do any transaction I can do in the Azure portal. Here, I'm going to go ahead and upload a file that contains some order data. And I can do that here. I can do that in the Azure portal. And to see, I run a SQL query, a Cosmos DB query, and I can see the count of the transactions uploaded. Now, I want to verify that. I can go to Azure portal and I run the exact same query to get a count on that container, and I see those items, the item count has been updated there as well. So it's the exact same database. Now, every single mirror database comes with a SQL analytics endpoint. This brings the warehouse BI experiences together. And here, because the data is in Delta, I can start running T-SQL queries. And you'll see the count right here, the exact same count that's matched before. I can also, as a low-code or no-code or a citizen developer, start writing visual queries. Without writing a single line of code, I can just start dragging and dropping tables into my canvas and start doing very complex joins without writing any T-SQL at all. Fabric is auto-generating all that T-SQL for me, and I can get instant results. Again, all on that replica. Now, I talked about being able to control and configure your mirroring. I can start and stop mirroring at any point in time. That's in your control. I can go ahead and look and monitor the status of my mirrors. See what tables have been mirrored, and at what point in time it was last refreshed, and I get a holistic point of view. Now, I can also go ahead and configure mirroring. Previously, you saw I picked all the tables from Cosmos DB to mirror over, but I may not want to do that. I might want to sub-select some tables, maybe some schemas. I might also want to know if there are going to be some issues before I mirror the data over. I can do all of that right here. It's all in your control. So here in my workspace, I have all my mirrored databases. Cosmos DB, Snowflake, SQL DB, all mirrored right here. And I can easily create a virtual warehouse in Fabric. I can go ahead and select one of the SQL Analytics endpoint. And once I'm in the SQL Analytics endpoint, I can start adding my mirrored databases as well in here. I just do a plus warehouse, and that brings up all my mirrored databases, all my SQL Analytics endpoints, all my warehouses in Fabric. I can bring them all together here. You see that right there in the Object Explorer. I can see all of the tables in the different databases. And just like that, I can start writing queries that's joining across these different databases very simply. Now, what I can also do here with mirroring is I can share it. Like if in Fabric, you can share your artifacts, and I can share my mirror databases as well, so I can share it with data scientists, with analysts, to go build their BI reports and start building their ML models. And all of this is just one click. I grant access so they can also get real-time insights. Data scientists can go build a lake house. Josh talked about this. Create a simple lake house. Now, in the lake house, all I have to do is go create a new shortcut. It's a shortcut, not data duplication, data movement for the data scientist. Pick that mirror database and pick the tables that I want to build my models on, and that's pretty much it. Those shortcuts are created, and I didn't have to move any of the data for my data scientists. And just like that, with one click, I can start building a new notebook and start building models. But here you go. I can also view those Parquet files that have been replicated over and converted to Delta tables. And I can create that notebook, and I can build models, use Spark SQL capabilities, and what the business analyst, on the other hand, could do is go into the Fabric Data Hub. In the Data Hub, they can start building reports. They can pick the data set of the mirrored database, and they can start building BI reports. So here, you'll see all of the tables coming through, and just like before, I can go look at the count, and you'll see the exact same count of that mirrored database show up here. Now, data could be updating in my transactional database. Here, for this example, I've updated one item in Cosmos DB, and you can see the item count has gone up. Now, I go back into Fabric, I run a count, and guess what? That instantly, that count has gone up. And I go to my Power BI report, and I refresh it, and there you go. Item count has gone up. So with mirroring, I've done two things. One is you don't have to worry about writing ETLs, long jobs, long processes, costly projects. You can use Fabric and Fabric mirroring to centralize your entire data estate. And at any point in time, you can get real-time analytics and AI on data that's coming from any transactional source. So we're launching the Mirroring Private Preview program, and you are welcome to submit your nomination. Once you submit your nomination, we will assess it. And this is by invitation only. We will contact you and get you into the program. So we welcome you to submit all your nominations. We expect to bring this out into public preview in early calendar year 24. So if your nomination doesn't get accepted for public preview when we open up to, private preview when we open up to public preview, expect that you will all get immediate access at that point in time. And in the meantime, if you haven't tried out Fabric, I would highly recommend that you get started today and you can sign up for Fabric. It's really simple, no credit card or anything. You can get started with a free trial and you can do that today. And there are lots more resources for you to learn from. And with that, folks, I want to thank you for coming to this session this late in the evening and staying with us. And have a great rest of the evening and a great rest of Ignite. Thank you.